my name is Umut Sevinç. I'm a freshman electrical and electronics engineering student at Bilkent University. Today, I will represent my Physics 101 lab project. In this experiment, I will calculate the equivalent spring constant when springs are connected in series and parallel. Before starting to the experiment, I want to mention the theoretical background of this experiment. In this experiment, I will calculate the equivalent spring constant in two different ways. Firstly, I will use Newton's first law. According to this law, if the net force applied to the object is equal to 0, the object either stays at rest or moves with a constant velocity. So, I will calculate the equivalent spring constant for the spring system in equilibrium by using this law. Moreover, I will calculate the equivalent spring constant by using special formulas for connection in series and parallel. I need some equipment for the experiment. First of all, I will use two identical springs whose spring constants are 14 Newton per meter. Also, I need a mass hanger and an object. Finally, I need an electronic scale to measure the mass of the object and also a ruler to measure the extension of springs. Now we can start the experiment. Firstly, I will measure the mass of the object. As you see, its mass is 104.52 grams. After that, I will measure length of springs. As you see, each spring has a length of 22.5 centimeters. In the first stage of the experiment, I will connect springs in series and measure the spring extension. As you see, total length of springs is 60 centimeters. So, I can find that the spring extension is 15 centimeters. Now, when I divide the weight of the object by the extension, I can find that the equivalent spring constant is approximately 6.8 Newton per meter. Also, when I calculate the equivalent spring constant by using special formula, I find that it's equal to 7 Newton per meter. In the second stage of the experiment, I will connect springs in parallel and measure the spring extension. As you see, length of springs is 26 centimeters. So, I can say that the spring extension is 3.5 centimeters. Now, when I divide the weight of the object by the extension, I can say that the equivalent spring constant is 29.3 Newton per meter. Also, if I calculate the equivalent spring constant by using special formula, I find that it's equal to 28 Newton per meter. Finally, there are some errors in the experiment. In the first stage of the experiment, the percentage error is 2.45%, and in the second stage, the percentage error is 4.5%. These errors may be related to my measurements, because the scale of my ruler does not have a high precision. Also, I use some rope and tape to connect springs. These also may have caused the increase in total weight and spring extension.